Okay, so let's see the first question, okay? Okay, so this is the first question. This is for from the trial MRSM paper. Okay, so let's see for question number 2, right? So the diagram 2 shows the launching of the water rocket. So the momentum of the bottle moving upwards is 0.8 kg ms negative 1. Okay, so the first question is, what does it mean by momentum? So momentum is mass multiply velocity. So is correct, you can mark your own answer. Okay, and then for B, state the function of the fins on the bottle. Okay, so is to make the bottles, okay, stable. Okay, so stability. Okay, and then the next one, right? So if the mass of the ejected water is 0.4 kg, calculate its velocity. So this is from the principal conservation of momentum, right? The total momentum before collision is same as the total momentum after the collision. So since this is the elastic collision, okay, so we use this formula. So M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. Okay, since you know the initial velocity both is 0, right? Because the bottle is not moving. So 0 is equals to 0.8. Okay, so this one is the already given the momentum of the bottle. Okay, the momentum of the bottle. Okay, plus this is the mass of the ejected water 0.4. Okay, so this is the velocity of the water you want to find. Okay, so you just move 0.8 here to this side, so it become negative 0.8. Okay, so the answer is 2 ms negative 1. Okay. Alright, the next question is, give one suggestion how to increase the velocity of the water rocket. So you reduce the mass of the water. Okay, use a plastic bottle. Okay, so the mass will be reduced, so the velocity will be higher. Right, so that is question number 2. Okay, so far do you have a problem? Because before I move on to the next question. Right. Okay, so the next one is, so number 3. So diagram 3 shows a natural phenomenon, okay, occurring during the day at the seashore. So land and sea have a different specific heat capacity, right? So the first one is, what is the meaning of the specific heat capacity? So amount of heat required to increase 1 degree Celsius for 1 kg of substance. Okay, so the keyword here, you must have the amount of heat, okay, and then increase 1 degree Celsius and also 1 kg. Okay, so 1 mark. So in the diagram 3, draw the air circulation and name its phenomenon. Okay, so you know the land has a low specific heat capacity, right? So during the daytime, it will be hot faster, okay, compared to the sea, right? So the hot air is a density is very low. So when the density is low, it means the hot air can go up, right? So the cool air from the sea will go to the land. So this is called as the sea breeze. Okay, so the phenomenon is sea breeze. So this is the circulation, air circulation for the sea breeze. So the hot air go up and the cool air go to the land. So what if during a night? What happens during night? So during night, right, the land, okay, the land cool faster than the sea, right? So means the air, the hot air from the sea will go up, Okay, and then the cool air from the land will go to the sea. So that one is called as the land breeze. Okay, so it's different. Alright, the next one is calculate the specific heat capacity of 10,000 liter of seawater if the rise in the temperature is 0.00256 degrees Celsius and the heat supply is 100,000 joule. Okay, and then this already give you that 1000 liter is actually equals to 1000 kg. So if a 10,000 liter means 10,000 kg. Okay, so you already give you the heat supply here. Q is actually the quantity of heat supply. So the quantity of heat supply is 100,000 joule. Alright, the mass, okay, we already convert it to from liter to kg. So there is a 10,000 kg. Okay, so C, you need to find the specific heat capacity, and theta is the temperature changes. So this one, the temperature rise 0.00256. So you just substitute. So you got this answer 3906.25. Okay, so this is the unit. But in case you don't remember the unit for the specific capacity, so just to write, okay, just write the value here. Alright. Alright, and then for for D, underline the correct answer in the bracket to complete the sentence below. Okay. You see, referring to the answer in 3B. So 3B. So 3B, the winds blows the faster during the hot afternoon. Okay, because hot afternoon means the temperature is very high, so the land will hot faster. Okay, so the hot air will go up. Okay, so this is the reason why the wind blows fastest during the hot afternoon. Okay, because the specific capacity of land is low, right? So means it's easiest to rise the temperature during the hot day. Alright, the next one, number 5. Okay, number 5. Is it okay for question number 3? Teacher, can I wait? As a teacher can 2D. Can I write you smaller amount of water? Smaller amount of water. If you use the smaller amount of water, then the next one. Wait, I think first. If you use a small amount of water, means the momentum of the ejected water will be low, right? So the bottle cannot go higher, right? Because let's see question number 2 first. Because you know that the ejected water also produce the momentum here. Because the ejected water, the momentum of the ejected water is going downward, right? So if you use the smaller mass, of course the total momentum produced for the ejected water will be low. So means the bottle cannot go higher, right? Is it okay, Alvin? Okay. Alright, the next one is number 5. Okay, so diagram 5 shows a lady A standing in front of yellow line and lady B standing behind the yellow line in a train station. A fast moving train passes by the lady. So the lady A lurched towards the train while lady B is not affected. So this is actually the Bernoulli. Okay, the Bernoulli. So since here, because the train moves faster, right? So at this area, the velocity is very high, right? So the pressure is very low, okay? So the pressure from outside here, okay, will push the lady A to the train, towards the train. Okay, so this is called as a Bernoulli's principle. Okay, for B1, compare the distance between the ladies and the train. So the distance between the lady A is shorter. Okay, so lady A is shorter the distance. Alright, and then the next one is compare the speed A flows between the ladies and the train. Okay, so the speed flows, okay, for lady A is faster here. Okay, is faster. Uh, who is Chen Zen Kok? PowerPoint what? PowerPoint I don't understand. Yes. What PowerPoint did I promise to send you for any PowerPoint? Hmm? Then the Chen Zen Kok asking what? I'm still waiting for you to send me the PowerPoint. What PowerPoint? Oh, oh, okay. Alright, the distance. Okay, the distance from the train, right? The ladies and the train. So this is the ladies. So ladies A, so this is the train. So the distance, this is the lady A distance, and this is the lady B distance. Lady B distance. So the lady A is shorter than the lady B. Okay, is it okay, Minji? Oh. Alright, the next one is compare the pressure of air exerted between the train and the ladies. Okay, so the pressure of air exerted between train A and lady is smaller. So I already explained about this because this train is more faster here. Okay, so at this region, the speed is higher. Okay, so you know when Dudi said when the speed is higher, the pressure is lower. So means the pressure is lower here for lady A, okay, between the trains and the lady A. So the speed is higher, so that means the pressure is lower here at this region. Okay, so the pressure of air exerted between train and lady A is smaller. Alright, state the relationship between the distance of the ladies and the train for the speed of air flow. So the greater the distance, the lower the speed of airflow. Okay, so the greater the distance, right? The greater the distance, okay, so the speed here is low compared to the lady A here, right? Okay, so the next question, state the relationship between air pressure and the speed of air. So the answer is the greater the air pressure, the lower the speed of air. This is a Bernoulli. Alright, complete the following sentence by writing in the space given. Okay, so passenger of a bullet train are advised not to stand in front of the yellow line because there is a force exerted on them due to difference in pressure. Okay, the speed here is high, so the pressure is low. Okay, this one, the speed is low, the pressure is high. So due to the difference pressure, okay, difference in pressure. Okay, still other example of applications that use the same principle. You can use wings in aeroplane, okay, or in the lab we use the Bunsen burner. Okay. Not the shorter distance. Which what question is that? Aerofoil. You have to say which part that use the aerofoil. Like you know the wings in aeroplane, yes, they use the aerofoil. Aerofoil is the shape. Is the shape. But you have to know where does the aerofoil shape is used in your daily life. So in the aeroplane, not the shorter distance. That one is for which question, Jingwen? Short distance. You mean for C, isn't it? Okay. So your answer is the shorter distance, the lower the speed, is it? What is your answer? What is your answer, Jingwen? Or maybe you can later you can message me private. Is it okay? Or you, okay. Alright, so can I move to next question? So next question is number 7. Okay, so this is the drawing. Okay, so the first question is name the type of lens used in the diagram 7.1. So this is called as a convex lens. Okay, so on diagram 7.1, draw and complete the ray diagram to show where the object is located. Okay, so the first one you draw from, okay, this is the image. So usually they give you the object, but then you have to draw the image, right? But for this question, they give you the image, but you have to draw the object, right? So it's a backwards, right? Reverse process. Okay, so the first one, starting from the image here, so you make a line, okay, until it passes through the center of the lens, okay, like that. So that is the first line. Okay, the second line, okay, from here, the straight line until here, okay, then stop, then straight line go to F. So the intersection between the two lines you draw, so that is the object. Okay, so this is how you find the object. Okay, how you draw the object. Okay, the next one is state two other characteristics of the image formed in the diagram 7.1. If you answer inverted, okay, it's wrong. Right? Why? Because in the diagram, it's already show you the image is inverted. So the question asks you two other characteristics. So that one is a bigger size. Okay, compare the object size of object and size image. So the image size of image is bigger than object. And then the another one is real, right? Because it's the image form behind the lens. So the answer is real and bigger size than object. Okay, for C part, diagram 7.2 shows a compound microscope. Right. Actually, who is the Zen cop? Is it in 5? Is it 5K? Because 5M no Zen cop, right? So, yes. Okay. Okay. Teacher, for the drawing diagram, is it okay if I draw the line for the first, then you pass through the focal point, Draw line parallel first, then pass through the focal point. Oh, you mean you draw this line first, or you draw this line first? Go from here, then yeah, can sure. Okay, the next one is compound microscope. So suggest modification that can be done to modify the microscope into a telescope, which will produce a bigger and brighter image and can be used for a long time without straining the eyes at normal adjustment. Okay, diameter of the objective lens. So the diameter of the objective lens is actually, this is the convex lens, right? So this is called a diameter. Okay, the diameter of the convex lens. So the diameter of convex lens should be bigger. Why? So the more light can pass through the lens. So you will produce a brighter image. Okay, so the diameter of the objective lens must be bigger. So there is more light that can enter or can pass through the lens. Alright, the next one is the focal length of the eyepiece. Okay, so you know the first lens is objective lens, and then the second lens is called as the eyepiece lens, right? I draw. Okay, so you use two lens, right? Okay, you use two lens for the compound for the microscope. Okay, so the first one here is called as the objective lens. Okay, so at the back here we call as a eyepiece lens, right? So the next one is the focal length. It should be shorter. Okay, shorter focal length of eyepiece. Okay, shorter focal length of eyepiece. Okay, so the reason for a greater magnification. Okay, or you can say can magnify the image. Also can. Alright, the next one is the position of the first image. Okay, so if you draw, right, if you draw, okay, so let's say this is the object, okay. So if you draw that, right, so this is the first image, right? Okay, so the position, okay, the position of the first image, okay, must be, okay, this is also the FE. This is for the microscope, okay. So this is FE, right? So the position of the first image must be at the same position as the FE, okay. So at the focal point of the objective lens, okay. Okay, can you wait for a moment? I try to find the ray diagram for the microscope. Wait, huh? Hmm. Okay. Done. Okay. Okay, so this is the compound microscope. So you see the image, the first image, right? Is at
Teacher,
the
you have a share
here,
screen.
at the eyepiece, KFE. Yes. Oh, I didn't share. Really?
Yeah,
Wait,
teacher,
wait, wait.
you can share.
I did share. Right. You can see, right?
Also don't have for teacher.
Of the first image is at the focal point of the objective. Okay. So here, okay. So at the first of the objective lens.
Panyus,
This one
Panyus,
is first, yes, yes.
we can't see the screen.
Yeah.
We cannot see the screen.
Yeah, I can hear you.
Okay.
You can see the screen.
Cannot.
Oh, okay, okay, okay. Wait, I I try to share again. Okay, can you see now? Okay, sorry. Right. So you see the first image is here, right? So this actually usually the eyes is here, okay, but this one they put it okay this way. So this is the objective lens, this one is the eyepiece. Okay, because the eyes is here, is from here. So this will become the objective lens. Okay. So you can see the first image, okay, is at the focal point of the objective lens here. Okay. So this is the first image. Okay, the first image we will produce here at the focal length of the objective lens. Okay, so and then it will draw a line here and here, then draw a line here, pass through the center. Okay, so you make it longer, so the image is at infinity. Okay, so that is the ray diagram for the microscope. Alright, the next one. Okay, so that is for the normal adjustment. Okay, for number 8, so this is the wave, interference of wave. Okay, so name point P. So this one is the crest, mid crest, right? So constructive interference. Okay, constructive interference. Okay, so explain how point P occurs. Okay, so it occurs when two crests overlap. Okay, so the constructive interference occur. Okay, or let's say the question asks you what happened here. Okay, here. So this one is also constructive interference. Okay, but this one is throw mid throw. Okay, if destructive interference, okay, is here. It means crest mid throw. Okay, so point P is when two crests overlap, constructive interference occur. Alright, the next question, diagram 8.2 shows a young double slit experiment using blue light as source. Okay, so underline the correct answer in the bracket to complete the sentence below. So point M, okay, point M is a dark fringes. So I already underline for you. So this is the line. So all this line that I connected, okay. So this one is actually the constructive. Okay, because you can see this one, the crest meet crest, right? So this is also constructive. So we produce the bright. Okay, but it asking you the M. So M is between the bright and bright. So in the middle here must be a dark fringe. Okay, so the answer is dark fringe. So this one you can try to connect it on, okay, underline it. Alright, for number 2, okay, what happened to the distance between two conservative bright fringes if the blue light is replaced with red light? So you have to know the wavelength, okay? What changed if we change the light? So what actually changed? So the wavelength will be changed, okay? So this one is the color, right? So red, orange, yellow, green, blue, indigo, and violet. Okay. To the right, okay, the lambda will decrease. Okay. But this one, it changed from blue to red. So blue to red means the lambda increase. Okay. So you use the formula, okay, for the interference. This is the formula. If there is any calculation, okay, for the interference, so this is the formula. Lambda is equals to AX over D. Okay, so you try to arrange it back. Okay, so we can see okay. So if you can see here, when lambda is increased, the X also increase. Okay, so the X will increase. Okay, is it okay? Right. Let's move to another questions for B. Okay, I do this first. So, right. An engineering student conduct a study on noise level produced by aircraft engine during takeoff. So the soundproofing materials lining the cabin floor is reduce the noise in the cabin. Okay, so table 8.3 shows the four aircrafts with their respective soundproofing characteristics. So this is the wave phenomenon in noise. So you have to choose. Okay. So based on table 8.3, state the suitable characteristic of the aircraft to reduce the noise level produced by the aircraft. So give reasons for the suitability of the characteristics. So the first one, of course, the wave phenomenon in noise simulator is destructive interference. Okay, so the sound loudness is destroyed. Okay, destructive interference, sound loudness is destroyed. Alright, the next one is soundproofing material. So porous, okay, because able to absorb sound. Okay, able to absorb sound. Okay, the next one is the thickness of the soundproofing material. So should be thick. So high sound absorption. So this one to reduce the reflection, right? Reflection of sound. Okay, so should be thick so it can absorb more sound. Okay, so the reflected sound also will be decreased. So this is the reason. So using your answer in 8C, determine the most suitable aircraft that can reduce the noise level. So since you use the destructive, porous, and also thick. Okay, so I choose R. Okay, for this one you don't need to put the reason like your essay question. Okay, so this one you just choose R. So no need to state the reason. That one is only for essay because when I mark your paper, some of you give the reason here. Mean copy back all the characteristics. Okay, no need. That one is only for the essay part. Okay, so the next question. Where is the diagram? Alright, maybe I forgot to. Okay, wait, I open the question first. Hmm. Hmm. Go to question number 9. Okay. Okay. So this is the question, right? So diagram 9.1 shows a softball player hitting the ball slowly, right? So diagram 9.2 shows a softball player hitting the ball with a greater velocity. Okay, so means this one the difference is the force. Okay, the force is different. Okay, so since this ball travel further, so mean this for the player for the diagram 9.2 give the higher force compared to the 9.1 here. Alright, so the next question is what does it mean by velocity rate change of displacement? Okay, rate change of displacement. Okay, so this is the answer. Alright, for diagram 9.1 and 9.2, compare the mass of the ball. Okay, since in the question they didn't give you any info about the mass, right? So we assume that the mass is same. Okay, so the mass is same here. Okay, and then the velocity. So the velocity of the diagram 9.2 is higher. Okay, so you see the question, how you answer the question. Okay, for the comparison question, you put the point here like this. Okay, because most of you, you put it in a sentence, right? You don't put in the point form. It's like an essay, you just continue writing. Okay, because I'm afraid, okay, in case in case the pemeriksa dia tak nampak you punya point, sebab bila you tulis semua dalam satu bentuk perenggan, kadang-kadang kita boleh terlepas nak tanda point tu. So if you do in the point form, so it easy for the teachers to mark your. So you know that this is the first one. Okay, this one the second one, this one the third one. Okay, so it much easier. So we know 3 marks. So this 3 point, 3 marks. Okay, for 1 point, 1 mark. Alright, so the next question state the relationship between the velocity and its momentum. So the higher the velocity, the higher the momentum, because P is equals to mv, right? So P is equals to mv. Okay, P is equal to mv. So P is equal to mv. So when the velocity is high, the momentum also should be high. Right, so the next one is the relationship between the change of momentum and its impulse. Okay, so the higher the change of momentum, the higher the impulse, because the meaning of the impulse is the change of momentum, right? Impulsive force, rate of change of momentum. Impulse, change of momentum. So is the meaning of the impulse is change of momentum. So that means if the change of momentum increase, the impulse will also increase. Okay. So this is the C part. Okay. Diagram 9.3 shows a girl wearing helmet and safety pads while playing on skateboard. Right. So explain why the girl needs to wear the helmet and the safety pad. Okay. So the first thing is the safety pad is made from a spongy. Okay, so it's a spongy. So actually this is the impulsive force. right? We use the concept of the impulsive force. Okay, so is spongy means the time of impact. If the girl fall, okay, so the time of impact will be higher. So the impulsive force is lower. Okay, so the formula is F is equals to mv minus mu, okay, divide by t. So if the time of impact increase, the impulsive force will be decreased, right? So the girl will not hurt. So 4 points here. Right, the next part, diagram 9.4, shows a man jumping from a building onto a safety airbag cushion. Okay, so as a safety officer, you are given a task to design safety airbag cushion that will be used to save people during a fire event on the building. Okay, so the first one, I think they ask you to describe about the material. I think the questions. Okay, about the material, these three aspects: material, size, and others. Okay, so this is, you can write okay, anything. Okay, so as long the answer is correct, acceptable. Okay, so this is like the SPM paper lah, right? The format is the same like this. All right, the answer should be, okay, soft material, okay, reduce impulsive force, okay, strong material, long lasting. Okay, remember, do in the table. Okay, please do in table, right? Large size, okay, so cover large area. Okay, so thicker, so the material must be thicker. So increase time impact, or you can say reduce impulsive force, but this one you already used the reduce impulsive force, right? So maybe this one you can change increase impact time. Okay, teacher, what if I put here reduce impulsive force? Is it okay? Yes, it's still correct, but you have to make sure that you don't use it more than 2 times, okay, in the questions. Alright, and then light. So should be light, okay, so easy to handle or easy to carry. Okay, so this is the, I think if you got this one, it's quite easy lah. Okay. Any questions? Large the momentum. For which characteristic?
For the compare one,
Compare one.
the ball.
The ball. Compare the for number 2 or number 3.
2 I also like larger.
Or you put the larger the velocity, the larger the momentum, is it?
Yeah, yeah.
Yeah, okay, sure, okay. Okay, for number 10. So this one is actually electromagnet. Okay. So this one you have to use, this one is the force, right? Force acting on the current carry conductor. Okay. So this is the experiment. So it said here, name the rule used to determine the direction of the force. So Fleming left hand rule. Okay. Right hand rule is used to determine the magnetic field of the current, the direction of the current. Okay, direction of the magnetic field of the current. Okay, right hand grip rule. So this one is Fleming left hand rule. Okay, because it has a battery. Okay, if it has a battery, then left hand rule. If no battery, okay, and then they use a galvanometer, that one is Fleming right hand rule. Okay, so you have to know the difference when you want to use the left hand rule or right hand rule. So this is the difference. You see whether they have a battery or whether they use a galvanometer. So the battery means left hand rule. Okay, if no battery and they use a galvanometer, that one is for right hand rule. Okay. And then the next one, based on diagram 10.1 and 10.2, compare the emitter reading, distance of copper rod move, and the magnetic field of the permanent magnet. So you see the question here. So it said, ask you to compare the reading of emitter. Okay, of course here the reading of the emitter for diagram 10.2 is higher. Okay, so the distant rod movement diagram 10.2 is further. Okay, 10.2 is further. So you see the D1 and D2 here. So this D2 is more further than D1. Alright, the next one is the magnetic field. Asking you the magnetic field produced. Okay, so the magnetic field is same. Okay, only the force is different. The magnetic field is still same. Okay, they use the same magnet, right? Okay, same magnet. Okay, and then the next one is state the relationship between the electric current with distance of copper rod move and the magnitude of the force produced. Okay, so the greater the current, the further the distance of rod move. Okay, one mark. So the greater the current, the greater the magnitude of force. Okay, you see here when the emitter is higher, the reading of emitter is higher, the further the distance of the copper rod move. Okay, so if you want to know which direction the copper rod move, then that one you have to use the Fleming left hand rule. Okay, and then the next one is C. Okay, this one is actually explanation. Okay, for explanation. So diagram 10.3 shows a wire connected to a galvanometer which placed between two magnets of opposite poles. Okay, so explain how the galvanometer. Okay, so this one they produce the induced current. So see, no battery, and also they use the galvanometer. So this question is about the induced current. Okay, so if you want to know the direction of the current, you use the Fleming right hand rule. Okay, so remember Fleming left hand rule is used to determine the force of the conductor, whether we move to left or move to right. Okay, but for the Fleming right hand rule, it's used to determine the direction of induced current. Since you know, if you want to produce the induced current, you have to move the wire, right? You have to move this wire to cut the magnetic flux, then induced current produced. So you already know the force because you move it, right? But you don't know the direction of the current. Since if it's battery, you know it move from positive to negative, right? You just can complete the circuit. But this one you don't know, okay? But you know you have force, you know which way you move, and you know the magnet pole. So you can use the Fleming right hand rule to determine the direction of induced current. So let's say for this one, so it moves from where to where? It moves from, go here, right? I think I draw it. If P to Q, like this, it will reflect here, right? So if we move like this, yes, okay, so means it move, okay, P to Q, because the pole is not so clear. Okay, you don't know which one is not, which one is out. But this one you don't need to know lah, just ask, because the question just asks you to explain. Okay, the first one you have to say, okay, the magnetic flux is being cut. Okay, so when you cut the magnetic flux, okay, that one point. Second point, induced EMF produced. Okay, induced EMF produced. Okay, the third part is induced current flows into the wire. Okay, then asking you the question, state the rule to determine the direction of deflection. So that one I already told you, use the right hand rule. So use the Fleming right hand rule. So 4 marks here. Okay. Sure. Can I write magnetic? Yeah. Sure. Magnetic field line is actually same as the magnetic flux. Okay. Sure, Elvin. Okay. The next one is Diagram 10.4. Okay, this is the modification question. So this is the AC generator. Okay, you know they use a slip ring, two slip ring here. This is the AC generator. So it asks you to modify. So it can be made to increase the output current to generator in diagram 4. State and explain the modification based on the strength of magnet, shapes of the magnet and others. Okay, so the strength of magnet, use stronger magnet. Okay, so increase the strength of magnetic field. Okay, so because you know if the magnet strong means there are more magnetic fields lines. Okay, so and then the second one, concave shape of magnet. Okay, this one even in the class also, and last week I think also I already show you the radial magnetic field is how is the shape, right? If you use the concave shape of magnet. So produce radial magnetic field. Okay, and then the third one, increase number of turns. Okay, so you use 2 or 3 layer of coil here. Right, so increase number of turns, so more current can flow. Okay, increase diameter of wire of coil, so this one is to lower the resistance. Okay, wire when the wire has a area surface of wire is higher, so the resistance will be lower. And then the last one is increase the speed of rotation. So more change in cutting of magnetic flux. So you increase the velocity or the speed here. Okay. So more magnetic field lines will be cut. Okay. So this is the characteristic and the explanation. Okay. For the question number 10. Alright. So number 11. Okay, so this is the light question. Diagram 11.1 shows a phenomenon of light that occur on a sunny day. Okay, so this actually the reach. What is the reach actually? So let's say you go to you travel, okay, with your car, okay, at the daytime. So when you travel, you thought you see water, right? Water on the road, okay. But when you arrive there, actually there is no water. Okay, so that is called as a mirage. Okay, so explain how the phenomenon occurs. Okay, so this one is actually the total internal reflection. Okay, total internal reflection. So what is the condition for the rules? Okay, rules or condition for the total internal reflections to occur. So the first one is must travel from denser to the less dense medium, right? And then the second one is the I must be bigger than C. Incident angle must be bigger than critical angle. So there's the two rules, okay, for the total internal reflection to occur. Okay, so that is very important. Okay. And then what is the critical angle meaning? Okay. Okay, what is the critical angle? Alright. Okay. So let's say this is the light ray. Okay. So this is the normal line. Okay, 90 degrees. So this is I, right? The incident angle. Okay. So when the light strike the surface here, okay, the reflected angle, okay, going this way. The line, the angle, the light going this way. Okay. So this one, what is the angle of refraction? Is 90 degrees. Okay, 90 degrees. So this incident angle, we call it as a critical angle. Okay. Yeah, so the meaning of the critical angle is the angle when the refraction angle is 90 degrees. Okay, that's that question is quite famous, right? They always ask you that question, what is the meaning of the critical angle? So critical angle is the angle when the refraction angle is 90 degrees. Okay. Okay, the next one. Okay, so explain how the phenomenon occurs. Okay, so the hot air on the surface of the road. Okay, hot is the less dense. Okay, less dense. Okay, so when during a sunny day, so this one the area be, near to the road. Okay, heat faster. Okay, heat faster. So heat faster means the air is hot. So the air is hot here. They know that hot air has the less dense. Okay, it's less dense. So hot air on the surface of the road is less dense. So add some words here. Dense. Okay, hot air on the surface of the road less dense. Okay, so since this one is the less dense, of course the upper part is dense, right? It's denser than the below part. So you know the light will travel from the upper part here, right? Because the sun is here, so of course it travel from the dense to the less dense. Okay, so the light from the sun propagates from denser to a less dense. So the light will bend away from normal. Okay, and then the third one is total internal reflection occur. Okay, the total internal reflection occur. So this is the 4 marks. Okay, so this one later, if you don't have time to copy my answer, I will put this answer in the group. Okay, so you can check your answer and copy, make a correction. Okay. Alright, the next one. Okay, this is the last one, right? Then number 12, we continue. And next week, we try to do paper 3. Okay, I will teach you. Maybe you already forgot, right? So long time we didn't do the paper 3. Okay, so 11.2, this is a periscope. Okay, so the optical object. So the characteristic, the first one, you choose a prism. Okay, prism is like this. Wait. Like this. Okay, 90 degrees, 45 degrees, 45 degrees. So this is a prism. We choose a prism because we want to total internal reflection to occur. Right? So the next one is prism because total internal reflection can occur. Alright, and then the next one we use the glass. Okay, high refractive index. Okay, high refractive index. Because then another info is refractive index is actually represent the density of the object. If the object have the high refractive index, it means the object is more dense. Okay, so the higher the refractive index, the higher the density of the object. Okay, and then the next one is the high refractive index. Okay, so easy for the total internal reflection to occur because you know, I already told you just now that high refractive index has the higher density, right? And for the condition for the total internal reflection to occur, they need the light to travel from the denser to the less dense. So the light travel inside the prism, right? So the prism must have the higher density, okay, compared to the surrounding. So if then the light can travel, can reflect back using the total internal reflection. Okay, so easy for total internal reflection to occur. Okay, dark. Okay, the inner layer of the periscope must be dark. Okay, so inside here must be dark. Okay, so the clear image will produce or minimize the minimize the light. Okay, minimize the light. So I choose K before prism. Okay, so this one, remember, you have to choose and you have to state the reason. Copy back all the characteristic. Okay, don't forget, choose and copy back the characteristic. So please, this one for number 9 until number 12. Okay, please, if you want to answer for this part, please do on table. Okay, so I think okay, this one D part until number 12. Okay, we continue next week and we continue paper 3 because some of you have a tuition night class, right? Okay, is it okay? If you have any question, you can ask at me. Alright. So see you on Monday for 5M. Okay. Thank you, class.
Thanks, teacher.
Okay, bye bye.
Teacher,
Oh, I see.
Puan Yus,
Yes, I'm here.
did you record the video?
Yeah, I
For-
record.
Okay, can you send it to me?
Yeah, I will give you the link on YouTube, okay?
Okay,